In this short video, we're going to think about how and why polymers are used in so many different places. So start by thinking about when you first wake up in the morning. What polymers do you use and come in contact with when you first get up, when you go brush your teeth, when you take a shower, before you even leave your home? Now let's say you're ready and you're out the door. Think about transportation. What kind of polymers are used in transportation? What kind of polymers are used in the room around you? And by what kind of polymers, I don't mean specific names of polymers, but where are the polymers used? And what types of polymers? What are their properties? And why are they used so much? So let's really focus in on that everyday household stuff. What's that mean? So when we wake up, we're presumably sleeping in a bed. The mattress is probably mostly polymer. It might have metal springs in it, but it might be nearly 100% polymers with the new, bed in a box type mattresses. Wood, if your bed is made from wood. Wood is a polymer composite. Your sheets are probably either cotton or polyester or cotton polyester blend, all polymer. Your pajamas, all of your clothing and that type of thing. The textiles are made from polymers, and they can be synthetic or natural. Let's say you hop in the shower. Why does your shampoo stay in your hand and not just run through your fingers? Well, it has a viscosity modifier in it, and that's a polymer. Same with toothpaste and a lot of our cleaning, personal hygiene and stuff. Lots of polymers are used in that kind of thing. Our shoes, whether they're leather or synthetic materials, polymers. The adhesives that hold the shoes together, polymers. If you really start to think about what you're in contact with, what about you? What about you? You are polymers and salt water. There's some other stuff, but the vast majority of you is made from polymers and salt water. And there's some other really important small molecules, but that's the vast majority of what makes us and holds us together. Bones are polymer composites. So from there we can talk about packaging, films, garbage bags, plastic sheeting, paints, adhesives, structural materials, fibers, electronics. You can't make a microchip without polymers. Elastomers, right? Things that stretch and return, polymers. Polymers are just really everywhere, from structural materials, from our sewer and water pipes, to the cars we drive, the buses we ride, the planes we fly, all of that. The polymers, without polymers, those modern conveniences just wouldn't exist. Fuel efficiency for airplanes, cars, buses, you name it, would not be the same because polymers reduce the weight, and that can improve the fuel efficiency. So polymers are really everywhere, and they're used so much. So why can polymers be used in so many different ways? And it's because there's so many different polymers and because their properties can change so much. So most polymers are very lightweight compared to other comparable materials with similar mechanical properties. So because they are lightweight, we can make more fuel efficient cars, buses, trains, planes, you name it. Without polymers, we can't make a hot air balloon that can literally float on hot air. The next thing I want to mention is toughness and transparency. Most non-polymeric materials that are transparent are not tough. Polymers have a unique mix of toughness and transparency. So what materials can you think of that are clear? Glass, crystals, that type of thing. They tend to be very brittle. But polymers can be made both transparent and tough, and that can lead us to bullet-resistant glass and other lightweight materials that we can use in place of traditional glass. The adhesive properties of polymers are remarkable. Glues and sealants, from when glues were first invented and were made from animal byproducts, are made from polymers. Natural glues or sealants, or however you want to phrase that, are made from polymers. So if you think about a barnacle adhering onto a ship or a pier, that natural sealant is still made from natural polymers. Polymers have remarkably low heat transfer. That's why we can use silicone oven mitts, because the heat transfer is very low. It's not that the silicone won't get hot, but the heat transfer from the silicone to your hand is very slow, so it makes a really great oven mitt. And I'm sure you guys have noticed this in another place. So have you ever, like, on a hot day, stopped at a convenience store and reached into the case to grab a soda or a Gatorade or a water, whatever it is, and it's in a plastic bottle? You grab that plastic bottle and it doesn't feel cold. If you grab the same drink in a glass bottle, it would feel really cold to the touch, because the heat transfer from the glass to your hand is higher, where the plastic bottle, the heat transfer is low. Most polymers burn quite readily, but not all. Some have great flame resistance, but those are engineered for that application. Another polymer property that is fairly unique to polymers is repeated flexibility. If you took a piece of metal and just bent it back and forth and back and forth and back and forth, you're gonna get it's eventually gonna break on that fold line due to the stress and strain of the material. But a lot of polymers can be flexed back and forth over and over and over, and it's not a problem. Rubber elasticity is another uniquely polymer property, where we can stretch something and it snaps back. This is really important, and is unique to polymers, and it's unique to the nature and shape of polymers, those long chains, and the thermodynamics of those polymers. Polymers are also just highly, highly processable, and the processing cost of polymers tends to be lower than a lot of traditional materials like metals and ceramics and glasses. So a lot of you have seen this processability in action. Many of you have used a 3D printer in the past. It wasn't so long ago, might be a long time ago to you guys, but it wasn't so long ago that it was common to have a CD read writer in your desktop computer or even your laptop. A CD writer, where you can record data on a CD, is essentially a mini polymer processing plant right in your computer. Because what you're doing is you are using a laser to encode the data in this polymer, in the CD itself, in that polymer CD. And you're doing it by creating grooves into that CD, that's how you're translating the data, the ones and zeros, into these grooves in the CD. And that this was essentially a disposable technology. You're with a polymer, you're just doing a read-write capability. It's pretty remarkable, very processable. In summary, because polymers have such a wide variety of desirable properties, are readily processable, and are relatively inexpensive, that's why they're used in so many different applications and have become such an important part of our day-to-day lives. Modern medicine really wouldn't function without polymers if you stop and take a look at what's going on with modern medicine. We'll get to that in a future video. Thanks for watching.